Question 4. The instruction is factor the expression. If we see here, the expression that we have is a quadratic expression, and the leading coefficient is 5, so that makes a little bit more difficult the procedure to factorize an expression like this one. I'm going to show you a procedure that it seems longer, and also can be complicated, or it seems complicated, but that is one possibility that you can use to get a factorization. There are other options, but and you can follow them. I think it's also okay, but I'm going to show you this procedure. So the thing that I'm going to do first is I'm going to make a product of the leading coefficient and the independent term. So that is 5 times minus 42, and that is going to give us minus 210. And with this, I need to find two values that if you multiply them, I get minus 210, and if I add them, I get the term in the middle, that is 29. Okay? One of the values must be negative and the other must be positive in order to get a minus 210 in the product. So to get those values, we need to guess a little bit, or you can get the factors of 210. If we get a half, we get this value, then we divide by 3, we get 35, then if we divide by 5, we get a 7, and divided by 7, the answer is 1. Now we need to play with these factors to know those two values. So just exploring a little bit more, we see that 6 and 35 is telling us that possibility, and the one that becomes negative is the 6. You will see why. Because with the addition of these two, we get 29. So this 29 is telling us that the largest number must be positive to get this value positive. And if we check with and if we see with the product, also is telling us minus 210. So now we have these values, and we're going to use these two values to decompose the one in the term in the middle, that is 29x. So 29x becomes 35x minus 6x, and then I write the last term, that is minus 42. Let me make a note that the thing that I am doing here is that I am decomposing this into these two, and now I'm going to make a grouping, a factorization grouping. Then I'm going to take these two terms and then these two terms to get a common factor. So that is going to be, if I take a 5x, I'm getting 5x plus 7, sorry, and then these two are negative, so I take a negative. I see that I can factorize a 6, is a common factor here, so this is going to give us x plus 7. At this point we see that we're going fine because these two are the same. So the final answer is going to be x plus 7, that is the common factor now at this moment, times 5x minus 6. 5x minus 6. So this is the factorization. Let me write here below the way to see the answer. So this expression is factorized in this way. Okay, it seems a longer procedure. Maybe you have another one and it's also fine, but this is, I think, it has a higher accuracy than other methods. Okay.